given polynomial h of x equals x cubed minus 2x squared minus 5x plus 6, find all the rational roots. Okay, first thing we'll do is check the degree of the polynomial. The degree is the highest power on x, it's 3. A third degree polynomial has a maximum of 3 rational roots. And we know that if it does have a rational root, it will be in the list P over Q of plus or minus parenthesis. Okay, we're going to put the factors of 6 on the top and the factors of 1 on the bottom. It's the factor of the constant over the factor of the lead. And then we're going to simplify and get the list plus or minus 1 or 2 or 3 or 6. So we've got 8 possible values there. Now we're going to be given a hint. Now when we're given a hint, it's a wonderful place to start. They're going to tell us to try C equals 1. And I'm confident if they give me that hint, it's probably going to work, but I need to show that. So let's go ahead and demonstrate that synthetic division by C equals 1 is going to give us a 0 remainder, verifying that C equals 1 is indeed a root, a 0 of the polynomial. So there's the 1 divided into the coefficients 1, negative 2, negative 5, and 6. There's no missing variables, so we're cool. Bring down the first number, multiply and add, multiply and add, multiply and add. Yay, there it is, 0 remainder. 0 remainder, and we're finished verifying that we have found a 0. In other words, C equals 1, the number we divided by, is a root because it gave us a 0 remainder. Now we're going to take that information and factor our polynomial. H of x is equal to x minus the root 1. Okay, so we've got x minus the 1. Now we're going to multiply that by the q of x, which is located at the bottom of the synthetic division. It's the coefficients 1, negative 1, and negative 6. We have to write that as a polynomial 1 degree lower than the original third degree polynomial. So we'll use those coefficients to write 1 times x to the second minus 1 times x to the first minus 6. And now I'm going to try factor by guessing to bust apart that second factor. Yes, we can write that as x plus 2 times x minus 3. Now, each number that's being subtracted from x in these first degree factors, I call them first degree because the highest power on x is the first power. All the numbers being subtracted are the root c. So the first factor represents the root c sub 1, which is equal to 1, the number being subtracted from x. And let's see, where we go now? Oh yeah, the second one, x plus 2. Well, we want to know the number that's being subtracted, not added. So that's x minus a negative 2. That means that c equals negative 2 is another root. And then for the last factor, we have the root, or the 0, c equals 3. So we found all 3 of our roots. Remember, it's a third degree polynomial, so we could have a maximum of 3 rational roots. We have all 3 of them, and they are in this list, 1, negative 2, and 3. No particular order. And I'm thinking, even though I'm not asked to graph it, I'm going to show you that these represent the x values for the x-intercepts of the graph of h of x.